Today we are going over combinations. And combinations are arrangements of objects where order doesn't matter. So we've talked about permutations, and permutations are arrangements where order does matter. And our formula used factorials. So when we are finding a combination, we are taking out the extra repetitions by dividing by our factorial. So today, when we're dealing with combinations, we are going to use the calculator instead of a formula. So when we are dealing with combinations, again, order doesn't matter. We will go to our calculator, and from the calculator page, press menu, and then probability, and then combination. And let's have NCR, and then parentheses pop up on our screen. So our first example, student council members have selected 10 students to choose from to fill the position of a 4-person committee. Each student can only fill one position. How many different outcomes are possible? So this one is different than the problem yesterday that asked to fill a president, vice president, secretary, or treasurer position, because each one of those spots is a different spot, and you don't want the person who you said for president to be your treasurer, and vice versa. Whereas on a committee, it doesn't matter what order they're chosen, but that they are on the committee. So for this, we have 10 students to choose from. So that's our total. That's N. And we are choosing 4 people. That is R. So we've got NCR. And then we've got our N, which is 10, and our R, which is 4. So we are going to type this in our calculator. It's NCR 10, 4. So go to your calculator, menu, probability, combination, 10, comma, which is down by pi, 4, those are parentheses, you get 210 possible outcomes. Problem 2, James is having a birthday party next week. His parents told him that he could invite 5 of his 20 friends to join him at a theme park of his choosing. Our first part of this problem, if he chooses to invite friends at random, how many different outcomes are possible? So again, we have combination because order doesn't matter. And we have 20 friends to choose from. So we've got a total of 20 and 5 friends that we can choose. So an R of 5. So we've got NCR 20, 5. So menu, probability, combination, 20, 5, parentheses, and we get 15,504 outcomes. Now, the second part of this problem says, what is the probability that he chooses the friends Bob, Bo, Bill, Byron, and Bruce? So this is one group of 5 friends. And it doesn't matter what order they were chosen in, they're getting to go to the theme park. So probability is 1 out of 15,504. Example 3, if 3 points are randomly chosen from those named on the rectangle shown, what is the probability that they all lie in the same line segment? So first off, we have how many points to choose from. What's our total number of points? We have 8 points total, and we need to choose how many points? 3. So we got NCR 8,3, because again, order doesn't matter. And we know order doesn't matter because it doesn't matter if you chose A, H, or G, and then could have also chosen H, G, A. They are all 3 on the same segment. So when we have NCR 8,3, menu probability combination 8,3, we get 56 possible outcomes. Okay, but that is not the answer to the question, because the question asks for the probability that they all lie on the same segment. So we need to figure out what 3 points lie on the same segment. So we've got one set of points, A, B, and C. We have another set of points, C, D, and E. We have another set of points, G, F, and E. And we have the last set of points of A, H, and G. So we have 4 sets of points, 3 points that are all on a line segment. So our probability would be 4 out of 56. We need to check and make sure this doesn't reduce. So we've got to reduce our fractions. 4 out of 56. And that reduces to 1/14. Okay, our next one. The Lotto Texas was the first Texas in-house drawing game starting in 1992. There are 54 balls that each have one number from 1 to 54 on it. The machine will choose 6 numbered balls randomly from the 54 available balls. The order in which the numbers are chosen does not matter. What is the probability of winning the Lotto Texas if you buy 1 ticket? So again, order doesn't matter. So that means that we are using a combination. So our total number of balls is 54. And we are choosing 6 of them. So NCR 4,6. And then new probability combination 4,6. And we get 25,827,160. And then we want the probability of winning if you buy 1 ticket. So that would be 1 out of 25,827,165. Okay, then we've got review from yesterday. First up, how many 4-digit numbers greater than 5,000 can be made using the digits 3, 4, 5, and 6 if each of the 4 digits must be used? Okay, so we have specific spots, so order matters. So we are going to use a permutation. So we have 4 spots to fill. 1, 2, 3, 4. And we have 4 different numbers to choose from. And each of those 4 digits must be used. So I know that several of you are already going that we should just do 4, 3, 2, 1. And I'd say that you are correct if it didn't say that it has to be greater than 5,000. But we have to have a number greater than 5,000. And there are only 2 numbers that can get us a digit that's greater than 5,000. For a number that's greater than 5,000. So our first place is 2. And then after we've chosen one of those numbers, we have 3 options left. And then after we've chosen one of those 3, we have 2 options left. And after we've chosen one of those, we have 1 option left. So 2 times 3 is 6, times 2 is 12, times 1 is 12. So we have 12 possible outcomes, possible 4-digit numbers. And our last example, we want to know how many ways can the letters in the word successes be arranged. So this is like the Mississippi problem. So we need our total number of letters. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers total. And then we need our repeats. So we've got multiple S's. 1, 2, 3, 4 of them. We only have 1 U. So I'm not really worried about that one. There's no actual repeats. We have 1, 2 C's. And we have 2 E's. So then again, we take our total. So that's 9 factorial over 4 factorial, 2 factorial, 2 factorial. So please remember, if you are using an Inspire, to type control divide first. So you get your fraction before you do anything else. So we've got 9 factorial. Remember the exclamation mark is down here next to the G. Pare it down. 4 factorial, 2 factorial, 2 factorial. And we get 3,780. Possible arrangement.